Hello dear friends, welcome to the lecture of numerical methods. In this lecture we shall solve problems on Hermite's interpolation formula. In our earlier lecture we have derived the Hermite's interpolation formula. We should first see the derivation of Hermite's interpolation formula, and the problem depending on this formula we shall solve now. I have written here one problem, and after solving this I will give a problem for your practice. Using Hermite's interpolation formula, estimate the value of log of 3.2. This is natural log, or that can also be written as ln 3.2, log of 3.2 from the following table. In the table the values of x, y which is log of x, and y dash which is derivative of log x, that is 1 by x, are given. So it is 3 at the values of x are 3, 3.5 and 4. So that means starting value we denote by x0. This is x0, x1, x2, and corresponding this will be y0, y1, y2, and this is y0 dash, y1 dash, y2 dash. And the formula we have derived last time is this one. Hermite's interpolation formula is h2n plus 1 of x is summation of this plus summation of the second term here. This is the formula, and to use this formula what we require is Li of x. So we have to first compute Li of x, and that means we shall write, we find the first we shall find first we shall find Li of x, I taking value I is equal to 0, 1, 2, and that means L0 of x. So which is L0 of x is equal to, and we have earlier defined what is Li of x. Li of x means x minus x0 etc., but x minus xi term is not there, and therefore here x minus x0 will not be there. So x minus x1, x minus x2. So that is x minus x1, x minus x2. Here x minus x0 is not there, and denominator is x is to be replaced by x0. So it is x0 minus x1, x0 minus x2. So this is the value of L0 of x, and now we will use the values here given in the table. This is the value of x1, this is the value of x2. So the numerator will be x minus 3.5 and x minus 4. The denominator is x0 minus x1, this is x0, 3 minus, that is 3 minus 3.5, and next is x0, that is 3 minus 4, x2 is 4, and that can be calculated. You see this is negative 0.5 and this is negative 1. So that means negative 0.5, and that will, the numerator is, so it is negative into negative will be positive, 1 over 0.5, and the polynomial, this product is x square minus sum of these two, that is 7.5 times x, and plus the product of this is 14, and 1 upon 0.5 is 5 by 10, that means 2. So therefore this will be actually 2x square minus 7.5x plus 14. So thus that we have obtained L0 of x. Similarly L1x is to be obtained. L1 of x, that will be x minus x0, x minus x2. X minus x1 will not be there, and denominator x is to be replaced by x1, x1 minus x0, x1 minus x2, or this will be equal to, this is equal to x minus x0 is 3, x minus x2 which is 4, and denominator is x1. x1 is 3.5 minus 3 and 3.5 minus 4, or which will be, see this is 0.5, and this is negative 0.5. Yes, and therefore it is minus 1 upon 0.25, and that is x square minus 7x plus 12, and this term is 4. 1 over 25 divided by 100, that is 1 by 4. 1 upon 1 by 4 is 4. 4 at numerator with negative sign. X square minus 7x plus 12. This is L1x. One more is remaining, that is L2x. L2x will be x minus x naught, x minus x1 divided by. Now this x is to be replaced by x2, x2 minus x naught, x2 minus x1, or which is x minus 3, x minus 3.5. You see the value of x, x naught and x1. Denominator is x2 is 4. This is the value of x2. That is 4 minus 3 and 4 minus 3.5. You see, this is 1 and this is 0.5. 1 upon 0.5, that is 2, and 2, and this is equal to 2 into bracket, that is x square minus 6.5, sum of these two, times x, and plus 3 into 3.5. So that we have to calculate. I have done this calculation. I have actually worked out this problem, and to save the time I will write this. So for numerical methods, it is clear that we should use calculator, preferably scientific calculator, and using the help of calculator we should do the calculation. So this L2x polynomial is plus 10.5, product of these two, 3 and 3.5. So these are the polynomials that we have obtained, L1, L0 x, L1x and L2x. Now after that we have to find out their derivatives. So we shall obtain now the derivatives of these polynomials. L0 x is further, so this is L0 x. So further L0 x derivative of this, that is L0 dash of x. So it is 2 into bracket, this is 2x, derivative of x square is 2x minus 7.5. We will keep this as it is, and L1 dash x, derivative of this L1, it is here minus 4, and derivative of this bracket, that is 2x minus 7, and next is L2 dash of x, it is here. So it is 2 into bracket 2x minus 6.5. So these are the derivatives we have obtained, and now we have to find out the derivatives value at xi. See, this is to be obtained at xi, and further next L0 dash at x0. So these two must be the same. If these two are different, the Li will be 0, but these values L dash is to be obtained at same suffix. These suffixes are same. So L0 dash x is to be considered as x0. And what is x0? L0 dash x0 is 3. And put 3, x is 3 here. So it is 2 into bracket, 2 into 3 minus 7.5. And this number is, so L0 x0, that is minus 3. Next L1 dash x1. What is x1? x1 is 3.5, and this is the value of L1 dash. Here we have to put x is 3.5. So it is minus 4, 2 into 3.5 minus 7, and that is that is 0. You can check, this is equal, and subtraction is 0. So further, so we have written L0 here, L1 here. One more value is we require, that is L2 dash of x2, L2 dash of x2. And what is x2? x2 is 4. So L2 dash of 4, and that is 2, and in bracket 2 into 4 minus 6.5, and this value is 3. So you can verify this doing calculation with the help of calculator. So thus we have obtained L0, L1, L2, this is L2x, etc. and this is L1. So we now can use these values in the formula. So the Hermite's interpolation formula is written here. So Hermite's interpolation formula is, now we can see this, and this is equal to now h 2n plus 1. What is n here? 0, 1, 2 means n is 2, and that means h 2 into 2 plus 1, that is h5 of x. N is 2 and h5 of x is equal to, now we can take the sum. So we may suppose this as 1. Now from 1 we have h5 of x. I takes value 0 to n, means first we put I is equal to 0. So it is 1 minus 2 x minus x naught, Li dash x naught, that is first term, and it is in bracket Li at x is x naught, here Li is 0, first term is 0, that we have to write, and next term is, so this is 0, this is 0, L naught x only, I is 0, that is first expression, L naught x whole square into y naught, that is the first term, and I have the values here, so I shall write here, that is the first term, plus the next term is, put I is equal to 1, so it will be 1 minus 2 x minus x1 L1 dash x1 multiplied by L1 x whole square y1. Putting in the we are writing only this expression, 3 terms of this expression, and then after completing this sum we will write the second term. So this is the second term we have written, I is equal to 1. Now the third term in the first part, that is I is 2, so it will be 1 minus 2 x minus x2 L2 dash x2 at x2, and L1 means L2 here, I is 2, L2 x whole square multiplied by y2. So that much is the first part. Now 3 terms of the second part will be continued as plus. So this is I is 0 first, x minus x naught L naught x whole square y naught dash, plus I shall write the second term further, x minus x1 then L1 x whole square to y1 dash, here it is derivative, and the last term will be x minus x2, I is 2, L2x whole square y2 dash. So thus we have only written the formula, and in the formula we have written the full form of this, and now the values we have earlier obtained, here are the values, what is L0 dash at x naught, that is here, so and L0 x we have written earlier, so substitute these values in here, earlier obtained values in this expression. So substituting the values in this expression we shall get, and also we have to use now the value of y, that is y0, y1, y2 here, y0, y1 and y2, and then y1 dash, y2 dash and y0 dash, y1 dash and y2 dash here, and therefore this gives h5 of x. Now we have used the formula, so I shall write the next step here, h5 of x and but you see the value is asked at this point, log of 3.2, and therefore we can put x is equal to 3.2, x naught etc. are given values. So we to find log of 3.2, we put x is equal to 3.2 in this relation, and therefore we have h5 at 3.2, which means log of 3.2 is equal to you see in this 1 minus 2, x is 3.2 minus x naught is 3, and so on. So this is to be carried out, L naught dash x naught, that is minus 3, and what is L naught x whole square? L naught x we have written earlier, and L naught x is, see, L naught x whole square will be, that is 2 into x square minus 7.5 etc. So this is to be multiplied by square of that, which will be 2 into 2 square of 2, I shall write in form as 4. So instead writing here, I will write the term below. This is equal to, so 1 minus 2, x is 3.2 minus 3, there it is, x naught is 3, L naught dash at x naught, this value is minus 3, and L naught x whole square, which is 4 into x square minus it is plus x square, it is negative, x square minus 7.5 x plus 14 whole square. This is L naught square, and what is y naught? Y naught is this value, 1.09861. So this is the first term I have written here. Now the second, that is plus 1 minus 2 times x, x is 3.2 minus x1, x1 is 3.5, multiplied by L1 dash x1, and L1 dash x1 is 0, so that is 0, bracket is completed, and then L2x, so L2x square, that is L2x is 4 into x square minus 7x plus 12, 4 square is 16, x square minus 7x plus 12 whole square, and then what is next term is y1. Y1 is this value, 1.25276, and next is plus 1 minus 2, x into x is 3.2 minus x2 is 4, and multiplied by L2 x2, L2 dash x2, that is 3, and square of L2x. So L2x we have already written, and it is its square is 4 into x square minus 6.5x plus 10.5. This we have value we have obtained earlier, its whole square is to be written, and y2. So what is y2 is this value, 1 point, so this is 1.38629. So thus we have written these up to this term. Next is x minus x naught, and that I shall write here, plus x minus x naught is 3 into bracket L naught x whole square, and actually this is repeated, see this is the same, so we have written this term here, L naught x whole square with this coefficient 4, so that will be repeated part. So it is 4 into x square minus 7.5x plus 14 whole square into y2 dash into this y naught dash, and y naught dash is see 0.333. So that is 0.333 4 times 3, and plus next is x minus x1. x1 is 3.5. So what is important is to write the formula correctly, write the full expression correctly, and put the values that we have already obtained, the polynomials, the Li polynomials and its derivatives, and rest are the values of x, x0, x1, etc. and the part of calculation. So 16, this is 16 x square minus 7x plus 12 whole square multiplied by y1 dash. y1 dash is this value 0.28571, and the last term here is x minus x2, that is 4, and the square of L2, that is already written here, 4x square minus 6.5x plus 10.5 whole square, and multiplied by y2 dash. y2 dash is this value, which is 0.25, and thus one thing is that, so actually I have written the value of x here, but not only I have written the value of x here. So for time being we write x as x only, because we have not written the value of x further. So this is x, and now we put x is equal to 3.2 in whole expression. Putting x is equal to 3.2, putting x is equal to 3.2 and calculating and simplifying, the expressions, we get. Now we should use calculators to do all these calculations. What we have to do here, 3.2 everywhere, wherever x is there, write 3.2, square it, then write 3.2, the product of this, get this expression, then square it, multiply that by 4, etc., and obtain the full expression for this. In this way we can evaluate, simplify and evaluate this expression using calculator. So this each expression can be obtained, and I will write now the direct results as after calculation. So that comes to be the first term. There are 6 terms. We have the value of this term after putting x is equal to 3.2, it is equal to, so log 3.2. Actually we have not used the value of x here, so let it be x only. We have, and then we will put x is 3.2. So it is log of 3.2. Everywhere we have to put x is equal to 3.2, and the expression becomes, the first term is like this, 0.556863 plus So you should do the calculations up to maximum decimal places, so that we will get the accurate result. Don't write approximate, or don't write only 3-4 digits, write as far as possible. And so because these are approximate methods, and we will get the more accurate result. So I am writing up to maximum places, decimal places. Here actually we have written 4 and 4, 8 decimal, up to 8 decimal places we have written, and the final result is 1.16314542. So this is the value of log of 3.2, which is correct up to 4 or 5 decimal places. So up to this, it is correct, and thus this gives the answer. So in this way we can use Hermite's interpolation formula to obtain the given obtain the required value. In this case, the set of values will be x, y and y prime. Now I will write a problem for your practice. See, I have written a problem for your practice on this side. Please note this. By using Hermite's interpolation formula, find approximate value of, again it is log of natural log of 2.7, and the problem can be solved in the same way, exactly similar way that we have solved this earlier problem. And you note that every time the function may not be the same. It may be log, or it may be sine of x, or it may be cos of x, or any other function. But what is important is the formula. We have to express the formula correctly, and then we have to obtain the polynomials L0, L1, etc., and their derivatives at the point given. And further, we should put these values in the expression, full expression, write the full expression, and note here the value of x is 2.7. So here we have used the value of 3.2, here we have to use the value of 2.7, and use calculator to simplify and obtain evaluate the expression. So please try to solve this problem yourself. Thank you for watching the lecture.